Hello everybody, welcome to this lesson whereby today we are actually going to derive the exponential form of a complex number. From our previous lesson, I showed you how we derive this Maclaurin series for exponential, sine and cosine, and we are going to use these three to derive the exponential form of a complex number. Okay, so the exponential form of a complex the Maclaurin series of the Maclaurin series for exponential. The Maclaurin series for exponential is this. Let me write it here again. E is equal to 1 plus x over plus x squared over 2 factorial plus x cubed over 3 factorial plus x power 4 over 4 factorial plus x power 5 over 5 factorial, and so on. Okay, that is the Maclaurin series for exponential. Now, instead of writing x, we are going to let x be the complex number j theta. Okay, so wherever we see x, we replace it with this complex number j theta. Okay, so if we do that, we'll have e j theta equal to 1 plus j theta plus j theta, that is squared, over 2 factorial plus j theta cubed over 3 factorial, okay, plus j theta power 4 over 4 factorial plus j theta 5 over 5 factorial, and so on. Okay, so we have let x equal to the complex number j theta, and we have wherever there is x, we have replaced it with j theta. Now let's simplify it further. This will be e power j theta being equal to 1 plus j theta plus, if you simplify this, j squared is minus 1. So here, instead of this, will be a minus instead of plus. It will be minus theta squared over 2 factorial. Since j squared is minus 1 and theta squared is theta squared, that is what we have. In this place, we'll have minus j cubed is minus j. So we'll have minus j theta cubed over 3 factorial. In this place, we'll have j power 4 is 1. So we'll have theta power 4 over 4 factorial. And here, j raised to power 5 is j. So we'll have j theta power 5. Raised to power 5 is 5. Theta power 5 over 5 factorial. Okay, that is what we now have. Now what we're going to do, we are going to separate the real and imaginary parts. We're going to separate the real and imaginary parts. So for the real part, 1 is real, minus theta squared over 2 factorial is real, then we have plus theta power 4 over 4 factorial is real. So this is the real part. Now for the imaginary part. The imaginary part will have, this is imaginary, theta, then we have minus theta cubed over 3 factorial, then we have plus theta power 5 over 5 factorial, and we factor out the j, which is making it imaginary. Okay, real part, imaginary part. Okay, now look at it. If you've been following clearly, you already know what this is. This is nothing but cosine. Look at it here. The same, the Maclaurin series for cosine. It's up here, and it's exactly what we have here. So this is Maclaurin series for cosine. So instead of writing this, we can just replace it with cos theta plus, what about this other side? Yes, you guessed it right. This is the Maclaurin series for sine, and we have it up here. Maclaurin series for sin x, cos theta, sin theta. So instead of writing this, we can just go ahead and write sin theta, okay, and replace our j there. And if you notice, this is the polar form of a complex number. This is the polar form of a complex number. So it means that e j theta is equal to that. And since the polar form of a complex number, if this is equal to this, and the polar form of a complex number is given by r cos theta plus j sin theta, it means that also the left hand side can be written as r j power j theta. Okay, so finally we have derived our exponential form of a complex number, and it is r e power j theta. Okay, that is our exponential form. I've just derived the exponential form of a complex number. R e power j theta. Okay, as simple as that, where r is the modulus, theta is the argument, e is exponential. You know what exponential is, just a constant. Yeah, that's it. That's the exponential form of a complex number. So if we summarize, we have three forms of a complex number. We have the rectangular, stroke Cartesian, which is given by a plus bj. We have learnt that. And two, we have the polar form. which is given by r cos theta plus j sine theta. You've seen that, and now you have seen the exponential, and now we have just derived the exponential form, which is given by r e power j theta. Three forms of a complex number. Okay, thank you for staying with me. This is Understanding Math.